Right. So good morning all of you. Good morning, sir. The summary of the last lecture, we have discussed this reciprocal lattice. Right. Now take a fresh page and put the heading Bragg's law. Bragg's law. Oh, properties of reciprocal lattice. Ayyo. Just leave one side. At the end, I will give that points. Leave one side and take the heading. One side, one side. Just we have to give the properties list. Right. Ready. Bragg's law. So what is this Bragg's law? Okay. So generally, now let us suppose this is the crystal. So what this crystal contains? This is the direct lattice. Direct lattice means what? It's a combination of some planes. Say yes or no? And these planes are having interplanar separation, right? The interplanar separation of any crystal, generally, it's order of angstroms. Order of angstrom. According to de Broglie, if you want to get a diffraction phenomena, you have to send an electromagnetic wave of wavelength must be the order of size of the object. Otherwise, it won't get a diffraction. Once again, if you want to get a diffraction phenomena, the wavelength of the EM wave, whatever you are using, light, X-ray, a neutron, electron, whatever it is, that should have the wavelength. It should be the order of size of the object. Then only we will get the diffraction phenomena. Okay, so we have taken crystal planes and we have understood the order is, the interplanar separation order is 1 angstrom. Then search for the wavelength order 1 angstrom. What you are having? X-rays. X-rays. But better than X-rays, neutrons are very accurate. Neutrons diffraction will get more information and more accurate also. But unfortunately, neutron sources are not available as readily as X-rays. Nowadays, you know, everywhere you have X-rays sources. Whenever any fracture is there, what you will do? You go for X-rays only now. That's it. So the neutron source is not that much readily available and it is too expensive. That's why we are using only X-ray diffraction. Okay, right. So, okay, fine. That's why we are using X-rays for this diffraction phenomenon. From childhood onwards, we are hearing two words. One is a reflection, another is the diffraction. What is the difference between reflection and a diffraction? Both are same or any difference is there? Right. Listen. First let me take this. Here we have a reflection and the next one is a diffraction. Here the diffraction, one more name we call, because this is a Bragg's law, that's why here we call it as a Bragg's reflection. Bragg's reflection or Bragg's diffraction, whatever it is. But what is this reflection? Ordinary reflection. Ordinary reflection. For example, what is meant by ordinary reflection? Now here is a light and this is the surface. The light incident on the surface and it will be reflected. Is there any particular angle for that reflection? You have to reflect here only, you have to reflect at 30 degrees only, you have to reflect at 45 degrees only. Is there any particular angle for that? That means the reflection occurs from any surface, say yes or no, at any angle. There is no particular angle. The reflection occurs at 30 or 45 or 60, nothing. And always reflection occurs from bulk of the material or from the surface. And one more, there is a possibility. For example, I have taken a full transparent or some fully reflected material, something like that. Then what will happen? Whatever the intensity of light incoming, the same will be reflected. That means there is no loss of intensity. So these are the three factors possible in ordinary reflection. 1 second. First you should know the difference between Bragg and ordinary reflection. Listen carefully. Ordinary reflection occurs from the surface, okay, and the next one, and occurs at any angle, no issue. And one more, there is a chance of getting 100% intensity. So maybe 100% intensity is reflected. There is a chance of getting 100% intensity reflected back and without loss of any intensity. What is a Bragg reflected? Listen, now I am sending X-rays. So Bragg reflection or Bragg diffraction, it's not occurring from the surface, it is occurring through the bulk. That means it will go inside and somewhere from the plane it will be reflected back. That's why you will say Bragg reflection and ordinary reflection. Bragg reflection, it occurs throughout the bulk. That's good. Occurs throughout. Sometimes they will ask in interviews, throughout the bulk. Next one. Here it occurs at any angle, but unfortunately this occurs at Bragg angle. What angle? That's it. Only at a particular angle which is called Bragg angle. That's good. And next, there is a loss of intensity. You won't get 100%, definitely there is a loss of intensity. So that's the difference between ordinary reflection and Bragg reflection. Clear? Right. Now come back to this. Now here, since if you take any lattice, these are the lattice points, and you know the order of this interplanar separations. If you take some planes like this, and this interplanar separation is an order of how much? That's why we have to choose any beam you can choose, but its a wavelength is of order of 1 angstrom. That's why the best choice is what? X-rays. Less wavelength, high energy. That's why I am choosing X-rays. Are you ready? Good. Now, okay, let us go back and discuss. Ready. So here I am taking X-rays. Not only you are sending one X-ray, you are sending a beam of X-rays. So let us suppose here we have a beam of X-rays. Let us say one beam, and this is the another beam. Could you please tell me what is the condition for constructive interference? Wait a minute. Constructive interference. The constructive interference, please try to recollect. So what we have discussed in intermediate, phase difference delta phi equal to 2 pi. Whenever two waves are interacting with each other or superimpose each other, the constructive interference condition, the phase difference must be equal to, everybody know that, I think. And one more relation is there, I hope you know that, that is delta phi equal to 2 pi by lambda into delta x, where delta phi is what? Phase difference, where delta x is what? Path difference. I hope this also you know from intermediate, I need not to explain, spend time here. That's it. But I want to find delta x, ma. Could you please tell me what is the delta x from this? Lambda by 2 pi into, what is delta phi? Come on, say lambda. Oh, not only 2 pi. 2 pi, 3 pi, 4 pi, what is that? N pi, more general. So lambda by 2 pi, sorry, more general, anything, into how much? N pi. So, 1 minute, even number. What is that? Even number. So, even number, how much it is? 2n pi. So, that's why the phase difference is how much? 2n pi. Pi gets cancelled, 2 gets cancelled. How much it is? Phase difference is always must be 2 pi, 4 pi, 6 pi, like that. For 2 pi also you will get constructive interference, but not only 2 pi, for all even numbers. That's why it is, shall I write it as a 2n pi? That's better. 2n pi. So that's it. And finally we got the condition for constructive interference. The constructive interference. The path difference delta x equal to how much? That's. This is the path difference. Is it okay? This is from intermediate only, so not a new one. Okay, now I am taking the X-ray diffraction. Now I am taking crystal planes like this, and the interatomic separation is how much? D. Now I am taking this is my first ray, which is going like this. Maybe you have studied in intermediate 1. Okay. Now this is the interatomic separation. How much amma? Or interplanar separation. And I am considering this is the second ray. Something like this. Is it okay? And if you observe carefully, and I am assuming, all of you, I am assuming this angle is theta. If that angle is theta, could you please tell me, are you observing? If this angle is theta, this is 90 minus theta, and this is, and this is also good. Now if you observe carefully, this is the first X-ray traveling like this, and this is the second X-ray beam traveling like this. So which is having a more distance traveled? Second one. That's why I'm taking the more distance traveled by the second ray. This is a D and this is theta. Come on, how much? This is a D and this is theta. How much? Now what is the extra distance traveled by the second ray? D sin theta plus D sin. I need not to do all those things. OA, OB, no need na. That's good. So finally what I get? Path difference. Path difference. Path difference is nothing but delta x, which is the extra distance traveled by the light, traveled by the X-ray. I think this much as well as this much. How much? Super. Already we have discussed what is the condition for constructive interference. Not only 2 pi amma, all even numbers. That's why 2n pi. If you substitute this, and you will get n lambda. So delta x is equal to. That's why 2d sin theta equal to. That's it. Good. So what is the Bragg's law here, or Bragg's condition? This is called Bragg's condition. 2d sin theta equal to n lambda, where d is the interplanar separation, where theta is the angle between the X-ray beam and the planes, and n is the order of diffraction, where lambda is the wavelength of the X-ray. Is that clear? First come on, write down. In the textbooks they will write OA, OB, OC. I am not writing all those things because you learned in 10th intermediate already. interplanar separation, you know that, and theta is the angle between, please write angle between X-ray beam and plane, and n is the order of diffraction, and lambda is the wavelength of X-ray beam. The interplanar separation DHKL, you know that, 1 over under root h square by a square plus k square by b square plus l square by c square, something like this. Path difference and phase difference formula. Phase difference is always equal to 2 pi by lambda into path difference. 2 pi by lambda into path difference. From that we got the path difference condition, that is n lambda. Delta x should be n lambda for the interference. And just we find the extra path travelled by the second ray, that we got 2d sin theta, that should be equal to n lambda. And please write this finally, 2d sin theta equal to n lambda, where d stands for interplanar separation, theta is the angle between the X-ray and the plane, n is the order of diffraction, and lambda is the wavelength of X-ray. All these things you have studied in intermediate. But now what is a new thing we are going to discuss here? Just wait for a few minutes. What is the new thing? Reciprocal lattice. You already studied this in intermediate, direct lattice, and we have to study a reciprocal lattice. Anybody knows what is this form called? There is one name for this, scalar form. What is the scalar form of Bragg's law? Means you have to say this, 2d sin theta equal to n lambda. Everything is a scalar. That's why this is called a scalar form. If you forgot, just write down. Scalar form of Bragg's law. Every quantity is a scalar. That's why it is a scalar form. 2d sin theta equal to n lambda. Right now. First problem. CSIR question. A narrow beam of X-rays, a narrow beam of X-rays, a narrow beam of X-rays with lambda equal to 1.5 angstroms, with lambda equal to 1.5 angstroms. I didn't spend much time on this because you know from intermediate. Let us proceed. A narrow beam of X-rays with lambda equal to 1.5 angstroms is reflected from an ionic crystal with FCC structure, underline that, with FCC structure, with a lattice constant, 6 angstroms, with a lattice constant 6 angstroms, full stop. The sine of the angle, SINE, the sine of the angle, SINE, sine theta, sine of the angle corresponding to triple one reflection, is A root 3 by 4, B root 3 by 8, C 1 by 4, D 1 by 8. Ready? In the entire problem, one more time please read and tell me what is the order of diffraction. Please read the question and tell me what is the order of diffraction. Is it given? Is it given order of diffraction? What is that? 4 4 enti? Any order of diffraction mentioned? Whenever order of diffraction is not given, always you have to take 1. Write that note. 4 into my number of lattice points. Order of diffraction. Order of diffraction is not given, always take 1. Ready? So, what is the Bragg's law? 2D sin theta equal to n lambda. Order is not given, that's why you have to take always 1. Everyone, please listen. Lambda given and sin theta he is asking, and how to find D. I hope everybody know DHKL. Amma FCC, BCC, simple cubic. All are cubic structures. For a cubic structure, what is the formula? Good. A is already given by, is it clear? Substitute and get sin theta. So 5 marks. Lambda given 1.5. So angstrom gets cancelled and get sin theta. 1.5 into root 3 by 12. Amma? Root 3 by 8. Next one. And one more point I want to say. Listen, all of you. Here you are saying n is the order of diffraction. For example, they are asking you to find the order of diffraction. In the question, he didn't mention anything about order of diffraction. Always you have to take 1. Ante that is the first reflection occurs. I will tell you what is the meaning of first reflection, second reflection, just wait for a few minutes. Sometimes he will ask what is the order of diffraction. That means you are solving for what? I got n equal to, Amma listen, very important. I got n equal to 1.99. I got n value equal to 1.99. And in the mathematics I got 1.99. Tell me what is the order of diffraction? No, 1. Order of diffraction is integer, not decimal. Is integer. That's why although it is a 1.99999, you should take only integer, integral part. What is that? 1. If it is a 2.00001, then only it is a 2. As long as it is a less than 2, the order of diffraction is 1. Are you understanding? Careful. So always we have to take this as the order of diffraction. So please remember, order of diffraction here it is 1. Come on. Just write a small note also. For example, 0.9 you got. No diffraction. No diffraction. No diffraction. Diffraction does not occur. Be careful. No approximations. No approximations. Always take integral value. Integral value. You have studied this thing 2 times in intermediate, where one is in physics, another is in chemistry also. Next problem. A beam of electron with kinetic energy 1 keV, a beam of electron with kinetic energy 1 keV is diffracted through a metal foil of cubic crystal structure with spacing 1 angstrom. What is the spacing? 1 angstrom. Full stop. What is the approximate value? Of Bragg angle for first order diffraction. Right, listen. First immediately write Bragg's law condition. What is the Bragg's law condition? 2d sin theta equal to n lambda. Everyone please listen. D, planar separation, you know. He is asking sin theta only, leave it. Order of diffraction is given as 1. What you don't know? That's it. You are sending electron. I don't know if you remember from quantum mechanics, we have given the lambda of electron. Lambda of electron equal to under root 150 by V, where V is not velocity, V is what? Potential. So this is answer in terms of what? Angstroms. Under root 150 by, what is this? 1K. 1K. K means 10 cube. Okay, so this is angstrom. So you have to find this value and take this lambda and substitute and get sin theta. Come on, do it. Gate question. Be serious. Don't underestimate. Oh, easy things. See, this is the question from TIFR. Ma 150 by 10 cube ante 0 0 cancel, root 15. 0.3 amma. 0.38 and babu. 0.38 angstroms. So 2 into 1 angstrom into sine theta equal to 0.38 angstroms. So that's why sine theta equal to how much? 0.38 by 2. 0.38 by 2 means 0.6, 0.1, 0.19. So sine theta equal to 0.19. Sine theta equal to 0.19. Amma? 10.96 అంటే nearly Next question, draw the diagram. It's a TIFR question. Question is there, write down. Over. A monochromatic beam of X-rays. Under that diagram, write down. If it is incomplete, you can draw later. A monochromatic beam of X-rays. A monochromatic beam of X-rays with wavelength lambda. With wavelength lambda is incident at, don't neglect, is incident at an angle theta on a crystal with lattice spacings A and B, with lattice spacings A and B, full stop. A condition for there exists maxima in the diffracted X-ray intensity. There exists maximum in the diffracted X-ray intensity. Amma, maximum intensity is possible for what? Constructive interference. Constructive interference condition is what? Path difference is equal to n lambda. Is that clear? Answer. There exists maxima in the diffracted X-ray intensity. He has given lattice spacings A and B as shown in the figure, and is asking what is the condition for maximum intensity. That means constructive interference. Anybody wants to say? Answer. Amma? 2a? Option A, under root a square plus b square. Okay. Try. See the diagram carefully. See, are you interested first of all? No, you are not trying. That's why you are not getting. What is path difference? Extra path traveled by the ray. Why don't you find the extra path? Why you are simply sitting like that? Answer. No, you are not finding the path difference. I ask you to find the extra path. Just draw the line and find the extra path. So, is it the extra path? And is it the extra path? Amma, what is this separation? A. If this is theta, this is also. This is also. That's why how much it is? How much it is? What is the path difference? Why you are going for B? We need interplanar separation, perpendicular distance, not horizontal distance, perpendicular distance between the planes. Interplanar separation is the perpendicular distance. What is the perpendicular distance? A. So more it is TIFR question, A and B given, that's why answer must be contain A and B. What? So what? Still doubt, Amma? What is the path difference? So this is A cos theta. Then what is the path difference? Extra path difference? 2A cos theta. So what is the answer? 2A cos theta equal to n lambda. Why you will get B? I didn't understand. B is the horizontal distance. Why you will get? What is the interplanar separation given in the question? Asal common sense ledu. Here he given clearly. What is this? A. If this is A, what is this? A cos theta. What is this? A cos theta. What is the total? Are you interested or shall I leave this class? You are not finding the distances also. What is the use of staying here? Why you are seeing like that? Do it. Next again TIFR. Intermediate problems also we can't do. Distance finding, that is also issue. Write down. A parallel beam of light, again TIFR. A parallel beam of light of wavelength lambda, is incident. A parallel beam of light of wavelength lambda is incident on a transmission grating with grove spacing, GROVE, grove. If it is a crystal, if it is a prism or a crystal, what you will say? Interplanar separation. If it is a grating, have you seen grating in your BSc? Have you done the spectrometer experiments? Spectroscopy, okay, write down. Grating with grove spacing D. See, whatever it is, what is the constructive interference condition? Path difference is equal to n lambda. Can't you find the extra distance traveled? Come on. Grove spacing D. At an angle theta I, as shown in the figure. Full stop. The plane of incidence is a perpendicular or is a normal to the grove. Full stop. After diffraction, plane of incidence is normal to the grove. Full stop. After diffraction, the transmitted beam is observed at an angle alpha, relative to the normal. Full stop. Which of the following condition must be satisfied? Please take the options. A, d sin theta I, option A, d sin theta I plus d sin alpha equal to lambda, of course n lambda. Option B, d of sin theta I, d of sin theta I minus sin alpha equal to n lambda. Option C. 2d sin of theta I minus alpha equal to n lambda. Option D, 2d sin of theta I plus alpha equal to n lambda. I request you, don't get tension, just take a perpendicular. If you are able to find this distance and this distance, your answer is over. Can you do it? If you don't know the geometry of 6th and 7th class, you can't do it. Once again, what is this? How much? This is? theta I alpha. This is the path. This is the d. This is the theta. Opposite side. Come on, say d sine theta I. D sine alpha. Answer. Which one? This one. Why? 90 minus theta. This is theta. Huh? Answer. Oh, this theta is 90 minus theta na. Okay, okay. Understand what you are saying. Oh, that is your trouble. But I have written cos theta only na. Okay, understand what is your confusion. Oh, you can say na, I have written maybe directly I have cos theta written. That's why you are seeing your faces. You can say na, maybe I have written directly. Come on, 90 minus theta. What is this? Theta. 90 minus theta. Happy? Come on. Whatever it is, it's the same answer, namma. ఇంకా స్కూల్ పిల్లలాగా theta 90 minus theta, what is this? Can't you write directly? Oh, understand your problem. You are getting sign here, answers the sign is only this one, that's why you are saying a plus b sin theta. Write directly amma, MSc students ఆ మాత్రం రాయలేరా? ఇప్పుడు హ్యాపీ అమ్మా? A 90 minus theta, you can't take it as some other theta. What is the problem? You can ask now, I will say what is the why I have written cos theta, what is your problem? You are thinking how got cos theta, how he got cos theta, and wasting the time. Improve, you are MSc students, not school children. Stop. All these things we have done in intermediate. I have not explained any new thing. So 2d sin theta equal to n lambda. This is the scalar form of Bragg's law. We are not here to discuss the intermediate things. Okay. So wait a minute. Very important. See, in those two questions, nothing is there. The second question, maybe by seeing the diagram will get come, nothing, just whatever the question is, what is the concept? Extra path traveled equal to n lambda, that's it. Whatever it is, TIFR, JEST, CSIR, does not matter. concept is important. X. Some other questions are given in your question bank and DPT. So Bragg's law, please solve those questions also. Every year GATE you will be having this question. Now take the fresh page, put the heading, Bragg's law in reciprocal space. Bragg's law in reciprocal space. Right, stop. Amma, very important. So this one you have not studied in intermediate, okay? So listen carefully. All those things are in intermediate book. If you want, you can read. Now it's ready. So here we are taking a reciprocal lattice. Already we have discussed in the last class. And again here we are considering the Bragg's law. Bragg's law in a reciprocal lattice. There is one interview question. Please remind me, I will explain. Bragg's law is a negative law or positive law? Negative law. Bragg's law is called a negative law. Why? They will ask this question. Just I will explain at the end. Remind me. Ready? Reciprocal lattice. Now I am taking here one direct lattice point and another direct lattice point here. Observe carefully. This is the direct lattice point. That's why I am taking it as a R1 bar. Is it okay? And this is also direct lattice point. That's why it is a R2 bar. You know, every direct lattice vector is given, every direct lattice point is given by a translation vector that I have taken R1 bar and now I am joining this. So I can take this as a vector R12 bar. R12 bar. Is it okay? R12 bar is nothing but R2 bar minus R1 bar. I hope you know that. That's good. And now what I am taking is, this is my first X-ray beam which is reflected from this point, and this is the second X-ray beam which is reflected from this point. Actually in intermediate you have taken only path difference of one ray. That is a simple case. Here if you observe carefully, there exists a path difference for first wave as well as a second wave also. This is more general. Observe carefully. Okay. So I am assuming this is the incident ray direction. What is the small incident? And this will be the diffracted or reflected, whatever it is. Reflected or diffracted. So this is the incident direction and this is the diffracted direction. I'm representing this incident direction with a unit vector called S0 cap. Shall I? Good. I'm representing this reflected or diffracted with a S cap, a unit vector direction. That's it. Okay, ma? Good. Now carefully observe. I'm taking this projection. Okay. and again here also I am taking, I hope you are observing. More general case I have taken. If you observe carefully, this is the extra path travelled by the second ray, and this will be the extra path travelled by the first ray. I have taken both. Both are having some path difference. Okay, not only single one. Careful. I want to represent with this something like this A, B, this is a C, and this is a D. Something like this. Could you please tell me now what is the path difference? Path difference. For example, I travelled 3 meters. Another person travelled 5 meters. What is the path difference? One wave travelled, for example, 2 meters. I travelled 2 meters. Another person travelled 5 meters. What is the difference between us? I want to leave. One person travelled 2 meter distance, another person travelled 5 meter distance. What is the difference? Why you are not saying? Why you are saying 1? Why you are saying 2? First case only I said 2 meters and 5 meters. I said one person travelled 2 meters, another person travelled 5 meters. 3 Sure I think come back. Ready. So one person travelled 2 meters, another person travelled 5 meters. What is the difference between them? 3 meters. So observe carefully, very important. You can't understand if you read the book. This is the first wave going like this, and some extra path covered, and this is the second ray, some extra path covered. And now I can take this is a AD bar, and I can take this is a CB bar, anything you can take, CB bar. So if you observe carefully, what is the path difference here? Path difference, just subtract, come on say. Earlier you added, the reason is, one is at the origin, the other one only is having the path difference. That's why you added both. Here it's not like that. Both are moving. For example, one person is at rest, another person is moving. What is the path difference? Whatever the distance travelled by the other person. If both are moving, what is the path difference? Different. You understand? Ready. The path difference, I can take this is AD bar minus CB bar or BC bar, whatever it is. Ready? Now carefully tell me, if I want to get this length, this is my R12 bar. Carefully observe, R12 bar. Are you seeing the board? If I project R12 bar along S cap, shall I get this distance? Say yes or no? So this is nothing but projection of R12 bar. Some distance they will give this R12 bar along. I hope you know this. R12 bar dot S cap. Ma careful please. Similarly, this is the CB. Again I am taking this R12 bar projecting in the direction of, that's it. Projection of R12 bar along S0. Could you please tell me? R12 bar dot. That's it. Now see, finally we got path difference equal to R12 bar dot S cap minus R12 bar dot S0. I can take out common. R12 bar dot S cap minus S0. Up to this any trouble? So what is this path difference? Already you know one condition for path difference. With your permission, is it a real space vector? Yes. That's why I am simply taking it as a R bar. Shall I take? That means the real space vector R bar dot S cap minus, carefully observe, this is the path difference. So according to Bragg's law or constructive interference, whatever it is, sorry, for constructive interference, I hope everybody know, delta x is equal to, I am not taking n, I am taking m lambda. Why I am not taking n means, again here we will write n1, n2, n3, you may get confusion, that is why I have taken m. Where m is what? Integer. Where m is what? Ante kada, first order, second order, third order, integer, that is good. So finally, delta x I got from this diagram. This is the condition for constructive. Come on everybody say. Okay. Now shall I bring this lambda this side? Then r bar dot S cap by lambda minus S naught cap by lambda equal to, if you want to read the book, you have to read 2 pages. But the whole content is this only. Listen carefully. So, if you observe carefully, we got this final condition. Carefully observe this bracketed term. This is the direction. This is also direction. By lambda. By lambda. Lambda units are what? Meters or centimeters. 1 by lambda units are what? Meter inverse or centimeter inverse. In which space you have meter inverse, centimeter inverse? Am I right or wrong? If it is a lambda, it's a real space. If it is a 1 by lambda, is that clear? K equal to what? 2 pi by lambda. So this S cap by lambda minus S naught cap by lambda, this represent a reciprocal lattice vector. Because having the dimensions of angstrom inverse. That's why I can write r bar dot g bar equal to, r bar is the real space vector, g bar is the reciprocal space vector. I am defining a more general reciprocal vector. What is that? G bar. That is equal to m, where m is what? Dot product of r bar and g bar should be equal to integer. So what is the meaning of this? I will explain. Just we have done mathematics only. Everybody know what is r bar? 1 minute. n1 a1 bar plus n2 a2 bar plus n3 a3. Everybody know what is the g bar already defined? h b1 bar plus k b2 bar plus l. And one more condition you have to remember. I hope you remember a bar dot b bar. That means we got yesterday. I told you. So dot product should be equal to 2 pi. A1 dot b1 is 2 pi. A2 dot b2 is 2 pi. A3 dot b3 is 2 pi. But any other is what? 0. I will tell you. Don't get tension. Come on, write down. Just a small diagram which is showing both waves are having an extra path. That's a more general one. But today read Ewald sphere, X-ray diffraction in the reciprocal space, because interviews they will ask questions. Be careful. Please read. Today the most important thing, Ewald sphere construction. Please read from the book. I will explain what is happening, but I can't give you each and every sentence in the book. You better to read. Don't simply copy. Small algebra, nothing else. Projection. If you want to find that distance, it's simply project that vector along S naught cap and S cap. That's it. Ready? Right. Ready, Amma. So this is the final result we got. Amma, listen very careful. We are trying to find the another Bragg's law condition in the reciprocal lattice. Earlier already we have done in the direct lattice. We got the scalar form. That scalar form is 2d sin theta equal to n lambda. But here we will get the vector form, because here we are dealing with the vectors. So whatever the answer you are getting in the reciprocal lattice, we call it as a vector form. So listen carefully, very important. r bar dot g bar equal to m, where m is what? You know what is r bar and what is g bar. And this relation yesterday, while I am explaining the reciprocal lattice, somewhere I have written k, I have derived k bar dot r bar equal to 2 pi. But that 2 pi, these are the primitive vectors. Yes or no? So that's why ai bar dot bj is always equal to 2 pi delta ij. Oh, that means what? If it is both are same, then only 2 pi, different 0. Now a1 bar dot b1 bar 2 pi, a1 bar dot b2 bar 0. Is that clear? That's good. Now by using that, could you please tell me what is r bar dot g bar? n1h, this is 2 pi, n2k 2 pi, n3l 2 pi, the remaining all product. Now ready, come on say n1h plus n2k plus n3l into, this is equal to, where m is, wait, okay, forget 2 pi, so scaling factor, n1h plus n2k plus n3l should be integer. Say yes or no? Okay. But you came from the direct lattice, na? So in the direct lattice already you have taken n1, n2, n3 are already integers. Are already? Yeah, already you define r1 bar and r2 bar, from there only we got. Are already integers. Now by seeing these two conditions, please tell me what about HKL? HKL also should be, that's it, otherwise you won't get a diffraction. So this implies HKL also must be integers. What is the meaning of this? Still we are not getting a what is happening there. Just we have taken a mathematics, and finally we got this relation. From that we got this conclusion, that's it. So this product should be integer, but already one set is already integer, that's why another set is also must be integer. This is what we get. Still the correct information we didn't get. Now we are going to construct a Ewald sphere. Are you ready? Sir, what is the meaning of HKL also must be integer? Good question. HKL also must be integer means, you know what is a G bar. What is a G bar? H B1 bar plus K B2 bar. HKL are integers means your reciprocal lattice vector G bar is a valid reciprocal lattice vector. That means HKL are integers, then only this G bar is valid. G is a valid reciprocal lattice vector. Wait a minute. Sir, how can I find this is the valid reciprocal, this is not valid reciprocal? That will be given by Ewald sphere. Once again, what is the condition for the Bragg's law, Bragg's condition or Bragg's diffraction? What do you get? Dot product equal to integer. If you do the mathematics, finally you got this conclusion. Now what is the condition for occurring a diffraction in a particular direction? HKL must be integer. What does it mean? Now how can you say that G bar is a valid reciprocal lattice vector? This can be understood by the construction of Ewald sphere. So Ewald sphere is going to tell you whether the diffraction occurs or not. That's a beautiful construction, because by seeing a direct lattice, can you say this plane gets diffraction, the other plane won't get a diffraction? Can you say like that? Impossible. But if you construct an evolved sphere corresponding to a direct lattice, that evolved sphere will tell you whether the diffraction occurs or not. Let me explain, okay. So I hope till now you got the conclusion. If there exists diffraction, your G bar must be valid reciprocal lattice. And don't forget what is the G bar. You have defined G bar as S cap by lambda minus S naught cap by lambda. That also don't forget. Now listen please. You will understand. After this evolved sphere, everything you will understand. Just listen. Now here I am considering some lattice, reciprocal lattice. Evolved sphere is in the reciprocal lattice. Now I am considering this is the reciprocal lattice vectors, primitive vectors B1 bar, B2 bar, B3 bar, okay. Now somewhere I am taking a carefully observe, somewhere I am taking the origin here, O, okay. Now I am taking the reciprocal lattice points corresponding to this primitive vectors. Something like this. Now listen please carefully. So what is this evolved sphere? One more time, I have taken this as the origin, okay, origin of my reciprocal lattice. Now I am sending the incident wave in this direction. Observe carefully. This is my incident wave. Incident wave. Incident wave direction is along which cap? S naught cap. That is my incident direction. Now this is the incident ray, okay, everyone. Let us suppose at this point there is interaction, but we have to check whether at that point what you are having a set of parallel planes. Every point in the reciprocal lattice is represented by a set of parallel planes. Now once again, this is my incident wave. Just pay attention for 10 minutes. Incident wave direction. Let us suppose at this point it is interacting, means here we have a set of parallel planes and that X-ray beam is getting diffracted from that parallel planes. Now evolved sphere is telling you whether those parallel planes will get Bragg diffracted or not, or whether there exists a Bragg reflection or not. Is that clear? Cool. So this is the incident. I am taking the incident vector. I am taking this point as A. This is the incident direction. Say yes or no? So I am taking this is a S naught by lambda. Is that clear? Now I am assuming at this point there exists a diffraction. That we will see later. Wait. Now this is the incident. Now take O as the origin, okay, and OA as the radius, and you have to construct, you have to draw a sphere, or else A as the center, because here there is no space. Anywhere you can take now. I am taking A as the center. Ready? So shall I take the sphere here? Observe. Some manipulations will be done, don't get tension. Sphere. Is it okay? Is it okay? బా ఇప్పుడు నేను స్పీరా డ్రా చేసేది స్వామి కరెక్ట్గా అడ్జస్ట్ అవ్వండి. ఓకే, 1 minute. Careful. Right. Okay, try to adjust, although it is not a spherical, just try to adjust. Now reason. Now this is my incident beam or incident X-ray beam. Now this is the incident direction, okay. So that's why I can take this as a, because either this radius and this radius both are same. That's why you can take either this or this. Don't need to get attention, okay, right. Now what is the point here? We want to check whether the point A is getting a diffraction or not. The point A represent a set of parallel planes. All those HKL planes, whether we are getting, in all those HKL planes, whether we are getting a diffraction or not. Is that clear? So what you have to do is very simple. From that A, take any direction. So I am taking upward. Shall I take? I am taking upward. Are you observing? Now if you take a line like this, if you take a vector like this, I am assuming it is a diffracted one. Diffracted one is what? Now if you see carefully, this is my S cap by lambda, just I am checking in this direction I am getting a diffraction or not. That's why I have taken S cap by. Good. Or if you want to check in this direction, you will take, what is this? S cap by lambda. Now, I hope you know you have to join these 2 points. Say yes or no? Now this is S cap by lambda and this is S naught cap by. Don't forget this. What is your G bar? So that means G bar equal to S cap by lambda minus. Okay, so what does it mean? S naught cap by lambda plus G bar. Say yes or no? S naught cap by lambda plus G bar equal to. Everybody understand? Now, please go back. I got this is the G vector. Okay, I am checking in this direction I am getting a diffraction or not. That's why I have taken S cap by lambda then I join this line, that means this is a vector. What is that vector? 0. From the definition. If you are checking in this direction, I will take 2 at a time. So this is my G bar. Am I right or wrong? Now see. Once again, please go back to the discussion what you have discussed here. N1, N2, N3 are already integers. Because this is the condition. This is the condition and this is the condition. So N1, N2, N3 are already integers. Then HKL also must be integers. When HKL are integers, if it is a valid reciprocal lattice point. If that HKL are not integers, we won't get a valid reciprocal lattice point. Say yes or no? Means what? See, I join this line at this point, do you have any reciprocal lattice point here? Yes. Say yes or no? Yes, so then this is the reciprocal lattice point and this is the reciprocal lattice point. Then this G bar is a vector joining. Is it a valid reciprocal lattice vector? Now wait. I am checking in this direction diffraction occurs or not. Then I have taken, this is the G bar, you know, from this definition. But unfortunately, do you have any reciprocal lattice point? Say yes or no? Here. Do you have point here? Cheppandamma. No reciprocal lattice point. If there is no reciprocal lattice point on the sphere, is this G is a valid reciprocal lattice vector? Then do you have diffraction in this direction? Now tell me, once you have drawn the sphere, wherever that sphere intersect the reciprocal lattice points, in all those directions, you will get a diffraction. In the direction in which the sphere does not intersect the reciprocal lattice points, you won't get any diffraction phenomenon. That is the meaning of G is a valid reciprocal lattice vector. When it is a valid reciprocal lattice vector, if it is a vector joining between two reciprocal lattice points. So whatever the direction you want, you can check. In this direction, for example, in this direction you want to check. Then whatever the G bar you are taking, this is valid. And this G bar is. That's why in this direction, diffraction does not occur, Bragg reflection does not occur. So the Ewald sphere, the beauty of the Ewald sphere is, without doing much mathematics, without doing experiments, theoretically, it can explain whether which Bragg planes are Bragg reflected, or in which direction we are getting Bragg reflection, in which direction we are not getting Bragg reflection. Because each and every point is a combination of HKL planes. Whether we are getting a Bragg reflection in this direction or not, whether we are getting a Bragg reflection in this direction or not. I don't know how many of you understand the main point of this. So once again, this is the Ewald sphere, the reciprocal lattice points I have taken. And I have taken, this is a OA, incident vector, anything you can take, it's not an issue. Here only you need not to take, anywhere you can take, because I am taking what? A sphere. So this is the incident vector. And okay, so now I am checking in this direction whether I am getting a diffraction or a reflection or not. So I have taken a vector, and after that I join this vector. Then definitely G bar must be a valid reciprocal lattice point. This is possible only when here we have a reciprocal lattice point. That's why wherever the Ewald sphere intersect the reciprocal lattice points, in that direction you will get the Bragg reflection. In other directions, that means where the Ewald sphere does not intersect with the reciprocal lattice point, we won't get any reflection, Bragg reflection. Is it clear? First draw the diagram, I will explain some points. But still some ambiguity is there. My advice, please read the book, then all doubts will be cleared. Still if any doubt is there, please ask. But main content, main theme I have given, and you please develop the English. Actually, MSc classes are easy to teach. Why? One day we will explain one content only, na? It's a 1 year. Coaching is very tough job. Why? Within 2 hours we have to give all the content. That's why maybe sometimes you won't get that blanks fill. That's why what you have to do from your side, you have to read the book. Then it will be cleared. Please try, don't neglect. అంటే మాది 20-20 మ్యాచ్, 1 ball 20 runs. Is it possible? Why? No ball, free hit, no ball, free hit. Why it is not possible? Nothing is impossible. Cricket to interest boy. Actually, in our childhood, whenever cricket is going on, we will bunk the college and we will go out and sit in front of TV. Nowadays, maja ledu. Sachin Tendulkar era gone. Ante. Whenever Sachin Tendulkar out, we will come out of that. Everybody will off the TV and will come out. You please draw spheres. Maybe you have bangles, something, coins. Ankita, where is bangle? Come on. I hope at least 50% content if you understand. My humble request, you won't understand 100%, but read the book, definitely it will help you in the interviews. The meaning of GHKL is a valid reciprocal lattice vector. I hope that point is fulfilled. So once you take an incident and reflected, and if you join from the origin, so there must be a reciprocal lattice point. Then only in this direction diffraction occurs. Why that point must be there? If this point is not there, this G bar is a not valid reciprocal lattice vector. So no lattice point, that's why no diffraction or no reflection. but only main points I have written, but still you better to read the book, my advice, don't neglect. In interviews they will ask, what is the importance of Ewald sphere? So what is that importance of Ewald sphere means? It is used to check whether the diffraction occurs or not in a particular direction. In which direction we will get the diffraction or Bragg reflection. I have written these points, please read. All the k all the k values for which the reciprocal lattice points, because each reciprocal lattice points represent the k value. All the k values for which the reciprocal lattice points intersect the Ewald sphere are Bragg reflected. So this is the k value for which Bragg reflection occurs, and this k value no Bragg reflection because there is no point, and here yes Bragg reflected, reflection occurs, valid, invalid. Take any incident direction, and after that if you want to check in a particular direction whether the reflection occurs or not, you have to take a reflected wave and join that horizons, join the 2 points. If you get a valid reciprocal lattice vector, then there exists a reflection, otherwise no. Ready? But I can't discuss so many points about all these things. Please go back and please take the book and read and write your own points, whatever you understand. But the main thing is happening whatever I already explained. Okay, so how to check whether exists a diffraction or not. Now ready? And tomorrow we will discuss the most important thing, which planes are Bragg reflected and which planes are not Bragg reflected. That is called geometrical structure factor, that we will discuss later. Now ready? So here this is the another form of Bragg's law, everyone. This is the origin I have taken, okay, and in this direction I am taking incident. I have a valid reciprocal lattice point, no doubt. So this is my incident direction. Come on, say. With your permission, I will take it's a k vector k bar, incident k vector. Is it okay? Because this is origin and this is the lattice point, that's why this is a k bar. Now I am assuming in this direction the diffraction occurs. That means what? Here also you must have. Yes, yes. This is nothing but what? Now I am assuming this vector as a k prime. What is that? Okay, that is reflected. Reflected or diffracted, whatever it is. Listen. Now you are checking whether there exists a diffraction or not. That means you have to join these 2 points. Just now I discussed. So this must be a valid reciprocal lattice vector. And if you join this, and we can take this is a theta and we can take this is a theta. Why? because this side and this side both are same, this side and this side both are same. That's why these angles are same. Clear? Good. Okay, was now ready. So just now we have discussed a condition, S cap by lambda minus S naught cap by lambda is a valid reciprocal lattice vector. Okay, this one you have taken as what ma? K prime minus this one is what ma? K bar equal to G bar. This is the reflected wave vector, this is the incident wave vector, this is the valid reciprocal lattice vector. K prime equal to K bar plus G bar. Now K prime magnitude square equal to K bar magnitude square plus G bar magnitude square plus 2K bar dot. Is it okay? Now, because of this sphere, this magnitude and this magnitude both are same. Everybody understand, I hope. So, K prime magnitude equal to K magnitude. Now, shall I cancel these two? Once you cancel this, I am getting 2 K bar dot G bar plus G bar mod square equal to 0. Yes, you can say this is the condition, no problem. But some people will write in another format, K2, K bar dot G bar plus G bar dot G bar equal to 0. Because the G mod square is nothing but G bar dot G bar. Okay, so I am dividing this entire thing with 2. So that means K bar dot G bar plus G bar by 2 dot G bar equal to 0. Okay now? Now I am taking G bar common. Come on, say K bar plus G bar by 2 dot. So the another form of Bragg's law, vector form, K bar plus G bar by 2 dot G bar equal to 0. This is also okay, no issue. So that's it. K bar plus G bar by 2 is a perpendicular to G bar. Where is K bar? Where is K bar plus G bar by 2? This side, sure? Pakka? Because that is the half G by 2. What is this called? A vector form. Tomorrow Sunday, ma. Tomorrow carry 2 papers. I will tell you today evening what is my mood. Generally weekend, I will also become weak. I will see, depending upon the energy. One paper is EM theory. What is another paper? I will tell you. Bring EM theory common. Maybe tomorrow we will discuss waveguides. Once the waveguides is completed, next radiation, Poynting theorem. Then we are safe. Today we have done some problems on Bragg's law, and some more questions are there in the question bank, sorry, DPT. Please solve. And the scalar form we discussed, intermediate, and the vector form, that is from reciprocal lattice. We have discussed that also. Now the final conclusion, the Bragg's law is called a negative law. What is the meaning of that? Let us discuss and conclude. Anybody wants to say? Okay, now you attend one interview. They ask this question. What you will say? You can't say, no, I don't know. If you say I don't know, what they will think? Because it's an easy question, basic question. If a difficult question they asked, for example, it's more than beyond your knowledge, then you can say I don't know. If they ask what is the Schrodinger equation, will you say I don't know? What they will say? I don't know, go. They won't feel if you say a wrong answer in beyond your knowledge. They won't feel anything, and they won't check whether it is right or wrong. How you are approaching to the question, they will check. Everybody think in the interviews we have to say the right answers. No, right approach, not right answer. You are not going to give them PhD. You are going to get the PhD from them. That's why they won't expect everything you know. Just they will check how you are thinking, how your mindset, all these things they will observe. That's why always they will try to give the hints. Do like this, do like this. If it is like this, what will happen? Like that. Ready? Now, Bragg's law is called negative law. What does it mean? I want to ask a question. What is Bragg's law condition? 2d sin theta equal to n lambda. Just a few minutes back I made a statement. What is that? Tomorrow we will explain which planes are Bragg reflected and which planes are not Bragg reflected. You didn't get a doubt? Sir, Bragg's law is already there. Why to discuss that concept? I don't know how many of you understand my question at least. My English you didn't understand. Once again. We already explained the Bragg's law 2d sin theta equal to n lambda. Now what you are thinking, if there exists a Bragg's diffraction, you will apply that formula. Am I right or wrong? It is in your mind right now. Now again I said, tomorrow we are going to discuss which planes are getting Bragg reflection and which planes are not getting Bragg reflection. So that means what? Although Bragg's law is satisfied, we don't know whether really reflection occurs or not. But Bragg's law is not satisfied. 100% there is no diffraction, no reflection from that plane. That's why Bragg's law is called negative law. And it is a saying about not saying about positivity. I don't know how many of you understand. So if Bragg's law is satisfied, we can't say diffraction occurs. The reason is tomorrow you will understand. There is something called atomic structure factor or geometrical structure factor. From that factor only we will decide whether the diffraction occurs or not for all crystal structures. Bragg's law won't decide. So Bragg's law is called a negative law because if the Bragg's law is not satisfied, no diffraction. That's why it is called negative law. It is a saying about negativity. I hope you understand. Just right. But if Bragg's law is satisfied, we can't say there exists a diffraction. That's why this is called negative. It is 100% saying about no diffraction occurs, but this one it cannot say. That's why we have to take the help of geometrical structure factor, GSF. This will decide whether the diffraction occurs or not.